scenario of what you might be doing. You know, you want to start a business or a project where you want to develop an app that recommends users where to shop to find the best deals based on their preferences, for example. And so in order to accomplish this, you'll need something, you'll need data, right? You'll need data about the shops that you want to support. You need data about the users and what their behaviors are. And somehow you need to take all of this data and turn it into something that works to provide your recommendations. And that's what I'm talking about today, the strategy of taking this from, let's say, nothing into a working product. Now, of course, you also need, you know, the actual app development and the marketing and things like that. That's not in this talk. This is more of the on the data side and that strategy. Okay, so here's my sort of outline for how to accomplish that. And of course, it starts with organization. So what we want to do is make sure that we organize ourselves from the beginning so that we can go step by step to eventually make it to the goal, which is to make an automated process. So after you organize yourself, you'll collect the data. And so I'll talk about how to get that data, how to find data, etc. Once you have that, then you start what we call the pipeline. So taking that data and turning it into something useful for your final product. So those have the steps of data preparation, data analysis, and gaining insights. And you see that I sort of said, okay, we get to insights, and then we feed that back into the previous steps, because it's really an iterative process where you learn something, you need to go back, decide, oh, we need different data, or we need to change our data preparation, and do that really over and over again as you develop your product. Then we'll go to machine learning. So how do you take your insights into something, leveraging the power of machine learning, and finally automation. And please, just to say now, if you have questions along the way, just go ahead and ask. I'm happy to answer along the way. So first, data organization and data collection, which I'll talk about together, and even I'll just start with data collection to set the mindset. So what data should we collect? Well, a simple rule is just to collect as much data as you legally can, because storage is cheap. You can get gigabytes and gigabytes of data storage for relatively reasonable prices. So just collect as much as you can. Of course, you want to respect privacy, GDPR, etc. So what kind of data can you collect from your app or website? You can collect transactions, the user funnel on the websites, any documents. Maybe if your app is, you know, in certain locations, you can take the time and the location of those app usages, images, and of course always logs. They're boring, but they can be useful. And there's really a lot of kind of data you can collect. But what if we really have no data? What if we're starting from nothing? What do we do, right? I'm sure you guys are thinking that. Well, the thing is, there really is data to find everywhere. So you can look for public sources. Google has this nice data set search function. Has really a lot of data sets out there to just search through. There's Kaggle, which sort of supports, you know, it does competitions in machine learning, but there's a lot of data sets in Kaggle to find. A lot of academic studies do, you know, collect data and make that available. And really, you know, in the end, you can just search around online. There's a lot of resources out there that aren't in these first three, and just search around and try to find something. Of course, you should just be careful, because possibly for, you know, in these academic studies or other resources, the data will be released, but not for commercial use. So just be careful about that. And you can also, instead of searching around, you can find companies that want to sell their data, right? Because that's another business case. And so it could be, you know, competitors, it could be target clients, other companies in the same market or similar markets. But, you know, on the other hand, don't just pay for data that won't be clearly relevant. Okay. Yeah, one aside, of course, you know, you can also sell data, and so that can be a part of your of your business plan. And so in others, because others may be interested in it. And it's of course only useful if it's unique data that you collect, because otherwise, just like I said before, you can go find it out in the web somewhere. And it's okay, you have to be careful because you need permission from the data source to share it, and also you may need to do proper anonymization so you don't release private information, and so you respect also GDPR. Okay, so we have the idea about what data we want. Now, how do we organize it? So I know everybody wants to take data and plop it into an Excel spreadsheet. In my experience, that's okay if you want to present information, because Excel sheets are useful, they're easy to share and easy to look at information, but avoid them for storing data, because your data is going to quickly grow and it's just going to not be effective in an Excel sheet. And so you should really plan to bring in a database from the beginning. Now this requires some technical expertise, what type of database to use, how to really implement it, make sure you have the data versioned, and really doing the implementation. So you'll need some technical expertise for that. But it's important to have that from the beginning, because if you're going to be successful, the data is going to grow and you need to store it in an effective way. So how can you organize it? Well, one way is just to diagram it, and you can do it, on paper, sort of draw like, okay, what data sources I have, etc. But there are useful tools out there. So one is draw.io. So it's just, you can draw a lot of things. And the other more specific is dbdiagram.io. And this figure on the right is an example from dbdiagram.io. And it's actually one we started making with one of our startups in the last batch. And it really is one of the first things we did. So that's a useful tool. And the important thing is, yes, you can see from the figure, it does get technical eventually, but it's important to start by organizing your understanding, and that will then lead you to make a robust technical implementation. Okay. Then, so you've collected some data, you've organized it into a database, you know what's going on there. Then the next step is to really start the pipeline. So prepare the data and do the data analysis. The first thing to remember is that the data is messy. And so this is a little figure that I took from a Forbes study, and it just divides up the time spent by data scientists from data scientists, some survey. And the biggest portion of it is data cleaning. So it's turning this messy data into something that can be used in the later steps. And it's really, it can be a difficult process, it can be a long process, and it's important to do that at the beginning, and it's very important to make it reproducible, because as a data scientist myself, I've had a lot of problems where there were steps taken by somebody at some point and they're not reproducible. So, maybe the data set had something strange in it that broke the code, and somebody went into the data set itself and maybe edited it in a text editor and changed this one thing that was wrong. And then it could be years later and you get an updated data set and it has that problem again, and it could be a completely different person importing that data set, and that person has no idea how that problem was fixed. So it's better to put the time in at the beginning to make sure the cleaning process is reproducible, etc., so that it should just work easily, and you don't spend time later on fixing problems that were reinventing the wheel, basically. And so where should you put it? Well, you'll see, I'll say this a few times. Basically, you want to deploy the pipeline on the cloud, as well as the data, because that should also be there. It's fine to start small, do it on a laptop, etc. But your development should keep an eye on the cloud, that your data, your pipeline, etc., will eventually go on the cloud, because that's the where you can best continue to expand the pipeline, continue to expand the business, and make sure that all the resources are there. I'll talk about that a little more later too. Yeah, so there are a lot of cloud platforms to choose from, and here's a few of my recommendations, basically. So First, if you're analyzing, let's say big data and you're really aiming for large scale automation, then something like Google Cloud or AWS is going to be a good solution for you. There are also, a lot of other ones. They're good choices, and I would say they're a little more geared towards business insights. So maybe a little bit less on the deep tech side. So, it depends on what you need. There's IBM Watson, Microsoft Azure, and DigitalOcean. So, it's worth looking over all of these to see what is best. We'll note that the Elevate startups do get free credits, so that's a good reason for getting in with Elevate. And how do you choose these? So you have so many options here. I would say to follow a few basic rules. One is developer experience. So don't have your developers go to some platform they're not used to. So just choose where they have the experience, because that's going to be going to have the minimal development time. Cost, you want to check cost based on your needs. Some platforms, maybe have higher costs for a large data volume or processing power, or whichever tools you want to use. There's Google machine learning, for example, which if you need that, then you have to see if that is appropriate. And then stability, I would say, if you already have a platform, or then there's not a good reason to switch platforms unless you really find something like a big change in cost or something that's just not possible. But usually, once you choose a platform, you can stick with it. Okay, so you have your pipeline set up, running through the preparation and some data analysis. Now you want to gain insights. And, gaining insights, I would say, really requires experience with data analytics and gaining experience with the specific data sets that you're using. So it's really a good, this is what you want to hire or collaborate with a data scientist, because they're going to bring that experience in doing this. In terms of structuring that work, here's two recommendations that I have. One is to follow a design thinking mindset, in the sense that you have a lot of questions that you want to ask about the data, and you want to brainstorm with the team which questions are out there, and you want to then narrow that down to some experiments that can be performed on the data set. And really, of course, that'll be repeated because you want to iterate often. And I recommend following an agile development methodology there, which really means you sort of you design, you develop, you test, you learn more, and you feed that back in, and you sort of keep iterating on the same process. And this is what I showed from the diagram in the beginning. It's really going to be an iterative process. You learn something, you modify the process, and it's a step-by-step methodology of gaining something that you can use for your really final product. Okay, and then we move to machine learning. So why, what is machine learning and why should we use it? So the point is to make first to make faster decisions than, let's say, a human could. So if you have like a bunch of pictures of animals and you want to choose which ones are cats, you can assume a person could look at, let's say, one picture a second, say, okay, that's a cat, that's a dog, etc. But a machine can do this, 100 times per second, 1,000 times per second. So it's much faster. And a machine can even make better decisions than a human. So for example, if the correlations in the data are not clear, so for example, in our shopping app, the behavior of the users may be, it's something that's not easily visualizable by a human, then you can say, okay, let's get a machine to actually learn what's going on in the data and extract that information to give you better performance. Now, before I go on, I want to emphasize that machine learning is really not the goal, right? It's a means to reach your goal. And so, to be explicit, if we look back at this figure, you can remove machine learning completely from this process if your business needs don't need it, right? You can just go directly to something that automated, not using machine learning. But, okay, in many cases, you really want to leverage it to get the most out of the data. So I'll talk a little more about it. So what is machine learning? Well, the goal really is to make predictions on new inputs, so new data that you haven't seen before, by using existing data. So for example, you can give a bunch of images of cats to whatever machine learning you have. And then if you give it a new picture of a cat, it should be able to tell you, yes, that is a cat. So like I said, you collect and prepare your training data. So this is the data that says, it's a label, basically usually a labeled data set. So these are cats, these are dogs, etc. Then you need to find a good model, and there are many, many choices out there, and there are even new models coming, being developed all the time. So there's a lot of possibilities out there for that. And then you train the model. You tell the model, here is the training data, please figure out how to understand that data so that I can make predictions, which is the last step. You ask that model to make predictions on your new data. So let me give really simple examples just to give you a feeling for what's actually happening under the hood when the machine is actually learning. And I think it's useful to sort of have this in your head because it's good to know what can be done, what's possible. It's sort of so you can push the development in the ways that make the most sense in terms of machine learning. So here's the example. We have just data of this is toy data of revenue versus marketing costs. So let's say you gather that data somehow, and your goal is to predict revenue for any marketing cost. So you want to sort of be able to draw a line on this figure. And so our model is a line with two parameters, a slope and an intercept. Right? It has the sort of the angle that it's at and where it in the up and down. and so how do you do this? Well, you can do it mathematically. It's called least squares fitting. You can do it manually. You can just draw a line on your data and calculate it, or you can use machine learning. So that's what I'd like to show you. So now there's a little more to look at here. So basically, what we've done in our machine learning example now is I've put this line at some random point, because usually you start at a random point and you have to then figure out where to go from there. And the top right panel here shows how far away the line is from the data in both the slope and the intercept. And you see it sort of gets closer to one point there. And you can think of it as a valley. So that point means that the line is as close as it can be to the data. And the red dot you see is where we are now. So that's the slope and intercept of this line that is just randomly chosen. And so what the machine is going to do, it's going to try to get to this bottom, this minimum point by taking steps in the direction of the slope. So basically, if you're standing on a hill and you want to walk down, you can just go the most direct way down. So that's what it's going to do. And it'll go step by step, and you can see it moving the parameters as it goes down. You can see that it finds a new, more direct way, and it starts going down that direction, and eventually heads directly down to the minimum point. And that would be then where you stop the learning, basically. I'm going to go through that again so you can watch it. And on the left-hand side, it's just plotting again it's the same line as on the right-hand side, just zoomed in so you can see it a little clearer. And you can see the line shifting its coordinates, at each point. So that's the idea behind machine learning. That's really what's happening underneath the hood in the core for many models, for many types of models. And all it's doing, when you actually do a more complex thing, it's doing this, but in a high dimensional space, more parameters, but it's the exact same idea. And one cool way to try it yourself is with this TensorFlow playground. So you can just go to this website and choose different kinds of data sets, and you can design a neural network that then figures out how to separate these data sets. So it's a little more, a little hands-on way of exploring this machine learning a little bit more in the context of a neural network. So that's something you can go play with yourself, and it's sort of fun. And so I want to give you a few ideas of like what machine learning can do by looking at a few examples. So one is Spotify. So a lot of you probably use Spotify, and what it does is it'll give you music that it thinks you like. And how does it know that you like that music? Well, it uses a lot of data basically, and something called collaborative filtering that makes suggestions based on your behavior and the behavior of people who are similar to you. And you can see they have this is a diagram from Spotify that sort of describes how they put all these pieces together to give you the actual recommendations in the end. So it's a lot of pieces with some different models underneath, giving you these recommendations. Another example is Google Ads. You get ads often, especially when you're online. They use a few different. Again, it's like in Spotify that they use a few models put together. They also use collaborative filtering. They also use something called transfer learning, which is interesting because it sort of says how do you apply generic data sets to cases where no data exists yet. So it's transferring that learning. And you probably noticed this on when you get these ads that it sort of shows you how it works, right? Yeah, for example, I once bought an axle for my car, like the piece that connects the wheel to the engine, because it was broken and I wanted to replace it. And usually you only buy one of these axles. You don't buy many of them. But as soon as I ordered it, I got more and more ads offering me axles. Of course, I don't need more axles. So you can see that it's doing the simplest thing there. It's saying you bought this once, you may want to buy it again, but it's not actually smart enough to say who would actually want to buy this again. So you can sort of see what's going on there. It's actually not that smart, but in theory, it could become, it'll become smarter and smarter in the future. Oh yeah, another example that's really interesting, of course, is self-driving. The sort of a big revolution in Industry 4.0. This is an example from Tesla. They have this visualization of how the car sees, right? And it's really deep neural networks trained on huge data sets and also models put together to make all the different pieces. And so it's a really interesting example of big data, big deep neural networks and MIDI models working together. That it's a huge revolution going on right now. That's super interesting. Okay, so how do you get there, right? So you start from, let's say, basically nothing, and you want to get to something powerful. And let's go back to our shopping example. We want to make the best shopping recommendations to our users. And I'm gonna basically, again, you want to follow this agile development, and you start really by making the simplest, most obvious matchings. You just use some heuristics, and you say, some simple calculation of what to give, and then you measure the performance and say, okay, are improvements needed here? And if so, okay, then let's move on to some simple machine learning. Let's say, linear machine learning, which means nothing too complex going on. And then you want to deploy that, measure the performance, and ask, are improvements needed? And if so, then go on, develop more complex machine learning, like deeper neural networks. And again, ask if improvements are needed, and keep going. And the point is not to go immediately to the most advanced machine learning, because that might just waste time and resources when really you just need something simple to gain the performance that you need. And so really it should be a step-by-step process. And by making these first steps, you give a baseline. You say, here's our performance at step one. We want to get to, we want to improve by, 20%. okay, let's go and develop that. So you really get very clear development steps from one to the next. I think, in my opinion, that's a good way to um, cleanly and efficiently develop something, that can be quite complicated in the end. Okay, so then we have all that together, and then we get to automation. And actually, I don't have much to say about automation except to do it on the cloud, because if you follow these previous best practices, then your automation will be easy. It'll be straightforward. You'll still need, of course, some development, but all the other pieces should just fall into place. Um, so you just put all of the data and all of the processing on the cloud. And the really nice thing is, okay, you have your product up and running, and your business is growing, and the resources just naturally expand. Well, it's easy to expand them. And instead of saying, oh, now we need to, buy a server farm and we need to hire people to manage the server farm, just put it on the cloud. And you have to pay for it, but it's more than worth it when you consider the cost that you would have to pay otherwise. Okay, so then I get to my summary. A few key points. Well, early organization will save a lot of time and effort in the long term. And it takes time, yes, but really to set that up well will save you from doing, big database migrations that are time consuming and difficult, pipeline reworking, etc. So it's best to organize it early. If you're worried about data, the useful data is out there. You might have to dig for it, but there's a lot of data out there to find. So it's worth looking around and seeing what you can find. I find personally that design thinking and agile methods will apply well to data science. So it's a good way to organize the work, and really aim for the cloud, because it'll allow you to grow your computing resources with your business. And that's all I have. So please let me know if you have any questions.
Thank you, John.